Hey, and welcome back to this series on my restoration and EV conversion of the 1978 bus. And this is a big milestone for me, this video here, because what you're seeing is the engine and transmission and axles all ready to be put in the car. And that's exactly what we're going to get done by the end of this video. But more importantly, what I'm also going to talk about in this video is why I chose to rebuild this particular year of transmission, which is not the same year that of the transmission that would have gone originally into this van. We're going to talk about late bay buses and the difference of the transmissions over the years between 1968 and 1979. If you happen to be doing an EV conversion like me, or maybe another type of engine swap, this video right here will help you understand what kind of transmission will not only work for mounting to your car, but also mounting to your custom motor adapter. So stay tuned and see it all happen. Let's start and look at kind of the overall history of these transmissions and how they evolved from 68 to 79. So from 68 to about 71, they had the 002 transmission, which is the 3-rib transmission, which had a little bit larger gearing ratio than what you'll see in the future 5-rib and 6-rib transmissions. Now, the smaller gearing ratio that they went towards helped with low-end torque in the 5 and 6-rib, but it's something I really didn't need, so it's actually better for me to have this 3-rib transmission because the gearing, the overall gearing ratio is larger, which is better for me because I have more low-end torque with the electric motor and I don't need gearing to compensate for that. It's actually better for me to have the larger gearing ratio. So that's one reason to go with the earlier 3-rib transmission. The other reason to go with the 3-rib transmission was because I don't know if it was on the 5-rib in starting in late 74 or 75 where the bell housing actually increased in size, but that is the deal breaker for me doing the 6-rib transmission that my car would have had in 78 was the bell housing was larger. And the reason the bell housing was larger was because they had the larger clutch disc. The EV West kit I got, the flywheel for that is made to service the most amount of years and types of Volkswagens, right? So the Volkswagen Bugs, the Karmann Ghias, and several other types of Volkswagens had this smaller bell housing. Well, at some point, I don't know if it was 71 or 72, they did go with a slightly larger clutch disc, which was the 200 millimeter was the one that was in the 60s and going up through the 60s. And then I think in the 71, I want to say 71 or 72, they transitioned to a 210 millimeter. Well, that extra 5 millimeter radius didn't affect the bell housing. So they didn't actually change the bell housing. But either on the 5-rib in 74 or 75, or for sure on the 76, the 6-rib, they went to a 228 millimeter clutch disc, which means they had to enlarge in the bell housing. Well, that's the biggest reason why I couldn't go with the 76 to 78, the 6-rib transmission, was because the EV West part, the transmission housing adapter, was made for the smaller, more common pre-74 002 3-rib transmission. The two reasons for getting the 3-rib transmission was the smaller bell housing that fit the off-the-shelf EV West parts. Otherwise, I would have had to have my own adapter plates probably machined by a machine shop, would cost a lot more money. And for the larger gearing ratio. So you might say, okay, well great, if I buy EV West parts for the electric vehicle adapters, I have to stay, even if I have a late bay bus, I have to stay with the early bay 002 3-rib transmission. And the answer is yes, but there's a caveat, another caveat that I had to learn the hard way. Originally, when I set off to buy a 3-rib transmission core, I was looking for a 3-rib bus, early bay bus transmission, the 002, and I found one and I bought one for a couple $100, and that's the one I was originally taking to the transmission shop to have rebuilt. What I didn't know is that was a pre-1971, it was 68 to 70 case, and there was one big difference in that casing that didn't allow me to install it into the body of the 1978 bus. And what that was is the changes in the rear mounting of it. between 68 and 71, the top of the bell housing was just rounded up here, and the rear mounting for that transmission was on the bottoms, which was kind of the same in prior years. Then I don't know if it was I think it was in 72, so like the 72 and 73 transmissions, they decided to change it and use those top bell housing mounts. So you see these ears up here mount to the frame to mount it to the top. And they continue that all the way to 79. So for the body of my car, I could not use the 68 to 71 002 3-rib transmission. I was pretty much stuck with the 72 to 73 because it still had the same bell housing size, but it moved to the top ear as far as for the mounting, which would work with the body of my 78. So 72 to 73, I had to go with that both for the body mounting and for the EV West bell housing mount. And just a couple other notable changes in these years. In I believe it was maybe 71, they decided to add this part to it. And what this is a throwout bearing guide. The throwout bearing guide goes around this, and it's used as a guide for it. I believe prior to 71, they just didn't have this. It was just the drive shaft. If you happen to buy that Kennedy Stage 2 clutch, it comes with this extra piece here that I did not mount to the mount inside here into those into that center there. So in the 71 and higher, you pretty much can't mount this optional part to the clutch because it'll interfere with it. Doesn't go around the clutch sleeve. So, and you really don't need it because that's essentially doing the same thing the throwout bearing guide is doing here. So we don't need this optional part because we have that throwout bearing guide. The other thing, like I mentioned, is the ears are now on the top. So that's how you can tell the difference between a 68 to 71 versus a 72 to 73 or 70, maybe part of 74, before they went to the 5-rib, which obviously is still a 3-rib, but has this top mounting ears. And then finally, there was a difference in the rear mounting, which I noticed. This part, I don't know when they changed this, but this was the old front mounting assembly. It just bolted on the same place as this one, but as you can see, the mounts are different. I don't know when they started this, but my 78 body requires this fork style front mounting plate, and so I had to buy this, but it bolts on in the same place, so that's interchangeable. So that's pretty much all the differences, and other than that, we shouldn't have any problems with the shifting nose cone or the axle placement or anything like that. Hopefully that will all look the same as the 6-rib and we'll have no mounting issues. But let's go ahead and get started on getting this thing installed in the car. I don't know about you, but I don't own a transmission jack. So in order to safely lift the transmission up without it falling all over on me, I built this little board thing, and I'm not sure if this will work, but we'll see. Basically, I took some scrap wood here. I had a thing of scrap wood, and they already had holes on the end, so I went ahead and glued these pieces onto the side and then one onto the front, which leaves an opening that fits around my jack's center kind of ring there. So that will hopefully provide a little more stability so that the transmission isn't teetering on it. And when I saw these holes, I was like, oh, that's perfect. So I might be able to run a rope or strap around it to kind of strap the transmission in. I'll still probably have to hold it with my hand, but at least this will give it a little more stability here. So something like that. Okay, well, I got the transmission installed, and I'm not going to do a detailed tutorial on installing the transmission. It's pretty straightforward, but what I will say is I just took the lift all the way to the ground, so basically put the car on the ground. The lift is no help with this, and got my jack and my little board thing and put it on there and just jacked it up until it was in the place that I wanted, and then went ahead and bolted it on. So we have the 2 bolts lined up on those top ears. Of course, that's what it looks like from the inside, these bolts right here. Then on the front side, I bolted on this little plate here for those little forks, and they kind of go into that little rounded part on the axle. Got it lined up and installed into the shift coupling here. It's all the way in, and I've got my little rubber boot on and that nut cinched up into that little indent in the shaft. Got my ground strap installed. On the later bay buses, apparently the ground strap is on the driver's side. There's a little stud welded to the trailing arm mount here, and that's where it goes. And I just mounted it to one of the bolts there, made sure I put an antioxidant compound on it and made sure it was making good contact. I believe on early bays that bolt is on the passenger side and bolts to this stud on the transmission, which is slightly longer, but obviously it's different on the later bay. I luckily had this bracket that I kept, and I dug through my parts, found it, cleaned it off, painted it, and bolted it on here, and so it's secured. I've got a new clutch cable guide here, and I've got, of course, the clutch cable all put in, and I'll test that out later when it's down. But the next thing to do is to install my rebuilt axles. If you haven't been watching my channel very long, I'll put a link in the description of when I did these. I did these probably over a year and a half ago, so I rebuilt these. And I also have new axle bolts here. One thing I learned is that when you look at the fastener for this, it looks like a Torx head, but it's actually not. It's called, I think, a triple square bit. So I'll have a link in the description to this gear wrench 8mm triple square bit, and it's got the extra long shaft, which will help me to get around the boot and put these in. I'm going to torque them down to, I believe the manual says the axle bolts are 25 foot-pounds of torque. So I've got my torque wrench set to 25 pounds, and I'm ready to install those. So I'll bring you back in when that's done. Okay, a little bit of progress here. I think I'm pretty much done with the transmission here. We have the axles put in, the throwout bearing is installed, and the wiring for the reverse switch is all in. Notice that it might be hard to see from this angle, but those axles are cambered quite high, and part of it is because possibly that transmission with the smaller bell housing sits up a slight bit higher than the 6 rib would have, but more so it's just there's no weight in it. Now, as far as weight is concerned, the electric motor is going to weigh far less than the original gas engine behind the axles here, but yet I'm going to put batteries in and more weight in front of the axle. So before I even touch the torsion tubes, I'm going to just make sure I got all the weight in. That's for another day, but I'll definitely re-index those torsion tubes to set the right rear ride height. The only other thing I was going to do before we go to put the motor in is to check the shifting. So I had previously redone all the shifting, everything from the coupler to refurbishing the rod, all new seals, cleaned out the tube, all that stuff. So I was hoping that all I would have to do is play the familiar song and dance that every bus owner knows, where you unbolt the shifter inside and kind of wiggle around the lockout plate and get all the gears to shift and then lock it all back down with those 2 bolts. Unfortunately, that's not the way it worked. Where I am, nothing shifted right, and at this point I pulled out the shifter. That's why you could see right up into the car. But notice that my tube here, I'm in neutral right here, and neutral right here puts the cup of that tube right at the edge of the opening, the rear edge of the opening, meaning we're about an inch from being centered in that opening there. Now, I can't really lengthen anything, right? Because you've got the rear shift rod coupled to this front shift rod right here. This front shift rod is the part that has that little cup, and the rear shift rod, like I said, I refurbished it all and I don't want to touch it. So what I decided to do was remove this front shift rod, just take this piece out and modify it and lengthen it about an inch, because I can't really do anything about this rod. Now, why I have to do that because of that transmission is my assumption is sometime in 74 or 75, with the 5-rib or 6-rib transmission, the nose cone must have been about an inch more forward, and this is shorter. It's got to be what it is. I don't know how else to explain this. So I need to move it about an inch forward. The best way to do that, though, is to modify the front shift rod tube. The reason being is because it's a smaller piece. I could take it right out and I can, cut it and weld it up and do whatever I want. And they sell an aftermarket version of this. If I screw something up, it's much easier to replace this, and rather than the main shift rod tube, which has to go through this tunnel, which I did all this work on. I'm not going to change that. That's, again, another thing for another video, since I know this video is not going to focus on shifting. But knowing that that's the shifter problem, I still wanted to make sure the transmission shifted. So I came back here to the rear coupler and I started just manually shifting it by rotating, pulling real hard, rotating another way, pushing it. You get the idea. So I did that to try to make it go through all the gears, and the one gear I couldn't seem to get it into was reverse. Well, or so I thought. What I ended up doing was I took my reverse wiring off the switch and I pulled the switch out and I tested it. It closes when the switch pushes in. So I verified that the switch is working, and then I looked inside of the hole that the switch is in. You can't really see, but inside this hole you can see an arm in there. And you can see this arm, and when you get into reverse, this arm will pull back, and there's a tapered piece on it to where the switch is open, and then when it gets pulled back into reverse, that arm will push in the button and close the switch. What I ended up finding was that arm was moving when I got it into reverse gear. So that's not the problem. What ended up happening is these switches have these rings on them to seal them in, the soft metal ring. And what I did was I took the soft metal ring out and was able to run this in a few more threads, and then it worked perfectly, which tells me that this switch was not manufactured properly. And it looks like a Euromax or Pacifica Parts International part. Anytime you see anything with those two brands, just either return it immediately or throw it away. Those two brands are absolute junk. Their parts are a joke and they suck. So I went ahead and ordered a new EMPI switch. Worst case scenario, I might have been able to file this ring down and shaved it off to where it would start working, but I don't want to mess with that. So that's the fix there. So I know that having the correct switch will make this work. So at least I verified that works. One interesting thing I saw was, I don't know if you noticed this, but there's another, what looks like a reverse switch up in the front of the nose. And when I was going through the gears, what I found out is that switch actually closes when 4th gear is engaged. So I'm like, what the heck is that? Well, I did some research on the Samba, and it looks like what happened was in the 70s, they added that, may have been only a 1 or 2 year thing, but they added that additional switch there. So when it switches 4th gear, it would actuate, or it would electrically tell something, I don't know, it was a vacuum advance on the distributor or something on the carburetor to do something. And it was for either fuel efficiency or emissions. I'm not quite sure. But in the end, I don't really need that, so I'll just leave it there as a plug, but I don't see any reason to use that. Once the reverse switch comes in, I'm good to go. Now that I've verified that the transmission doesn't need to be taken out, there's nothing wrong with it, we can move forward with the motor installation. Well, we have the motor installed. I've at least got it bolted into the transmission here, and I was starting the wiring, and then I got a little confused and scared that I might have gotten something wrong. So let me explain to you how we wire these series wound DC motors up. So looking at our diagram, I've got the motor in here and it's facing the way we want to face with the drive shaft in the front here. Notice that there's 4 terminals on the motor. You've got S1 and S2 in the front and A1 and A2 in the rear. Okay, so there's 2 terms on this spec sheet. It's CCWDE, which is counterclockwise at the drive end, which is if you're looking at it facing the drive end, how is it turning, versus just CWDE, which is clockwise at the drive end. Well, how would you know what orientation you should do for your engine? Well, the simple answer to that is just watch a Volkswagen engine running, right? If you ever watch a stock Volkswagen engine, whether it's a Bug, Karmann Ghia, a Bus, whatever, you'll notice that if you watch the front pulley as the engine turns, the front pulley is turning clockwise, right? but that's the back of the motor. At the drive end of the motor, if you were facing the drive end or the flywheel, that's spinning counterclockwise for that orientation. So for the Volkswagen engine, our electric motor should be set for the counterclockwise at the drive end orientation. This is a DC motor, not an AC motor, right? If it was an AC motor, we just have 3 cables going into it, which are our 3 different hots for the different phases of the AC. But in a DC motor, all we have is a positive and negative. So why is it there's those 4 terminals on there? Well, that series wound DC, I'm not sure why it is like that, but I think the reason it's called series wound DC is because I think the front and rear stators are kind of disconnected in some way so that you can do the different clockwise or counterclockwise orientations. Notice that 2 of the terminals are always strapped together, and the other 2 terminals are where you put your positive and negative. And typically the negative will go on the front and the positive will go on the back. So there's how I wired it, just like the diagram, the counterclockwise diagram, where those 2 are strapped together on the left or on the right, and then I have my negative and positive here. And I went on EV Album and I saw a Volkswagen Beetle that had it reversed. They had the series strap on these 2 terminals, and then they had the negative and positive on these 2. And I thought, well, maybe I did something wrong. And which would be bad because I would have had to probably pull this whole motor out and re-clock that adapter plate from the last video where I put that adapter plate on. I might have to rotate the whole motor 1/8 of a turn to put these studs at the top so that I wire into those and bridge those. But good news for me, there's 2 ways to wire each of the orientations. So notice that they say the counterclockwise, the preferred, really what they should say is common because it doesn't really matter either way, is connecting A1 to S1 and then connecting your positive negative A2 to S2. So if I connected A1 and S1, that's the way that guy had it. These 2 are connected and then negative and positive. But the alternate approach, which is just fine too, is to connecting A2 and S2, which is how I have it, A2 and S2, just like this diagram, and my negative and positive. Either way, it will spin counterclockwise. It doesn't matter. Now, if you have determined that your motor has to spin it clockwise, then you'll go to the second directions here, which is the CWDE. This one's interesting. Connect A1 to S2. So this is where you'll have those cross connections. So instead of connecting like that or like that, you're going A1 across the motor to S2. And if you recall in my previous videos, that's the way it was wired up because my friend who took it out of his Honda Civic had it wired up that way. He had it strapped across the terminals, and then if you do it that way, your negative and positive go on those opposing terminals. And again, you can do the reverse. You can simply go A2 to S1, which is crossing the series strap this way or this way. It doesn't matter. So whether you do this way or this way and then put your positive negative on the other terminals. So that's what makes series wound DC's motors very difficult to do reversing, because you have to have a double contactor that can switch all 4 of these terminals around. And what a pain in the butt. Whereas AC motors, you don't really have to do all that. The length of the wire between the controller and the motor should be as short as you can do. When I was figuring out how to orient the motor on that transmission housing adapter, I did it to where these left-hand studs were kind of as far to the top as I can get them, because my controller is kind of a little bit to the left of the motor. Therefore, my negative going to there and the positive going right to there will be my shortest orientation of these motor wires. Or, like I said, I could have rotated the entire motor up this way to where these terminals were at the top. It's either way, right? If I moved it 1/8 of a turn, these terminals would just be down here and it would be the same thing. So that's what you need to look for when you're determining how you want your motor rotated on there. And again, how short can you make these cables going into the motor? Because the shorter, the better. Well, reading about stuff and talking about it's kind of cheap, so let's do some real world testing here. So what I did was I disconnected my starter battery here, just so it's disconnected from the rest of the electrical system. And then I have put some jumper cables on it. I got the negative on the front. Of course, I got my series strap already on there. And I got a positive that I'm going to touch to the rear terminal, and that should spin it counterclockwise like we just talked about. I also lifted the car, at least the rear end up, off of the wheels. So notice I've got my wheels off in the rear and I've got it on jack stands underneath so that the rear is lifted up off the ground, and I have the wheels off, like I said, to minimize the amount of drag or whatever that motor is going to have. And then I also went underneath and shifted it into first gear. So what we should see is when I touch the jumper cable to the positive terminal, you'll see some sparks because it's going to draw a lot of current real quick. So I'll do it real quick. And what we should see is that axle right there should, from the inner orientation, we should see it spinning clockwise, meaning it's going forward. So let's take a look at that. All right, fire in the hole. And there we go. We've got our front drive shaft spinning clockwise, and we've got our wheels going forward. So good, we've got it wired up correctly. Well, there's a final shot of it all wired up. I'm sure I'll probably tweak those cables a little bit to clean them up, but that's the final wiring right there. Notice that for now, the motor is just simply suspended off that adapter plate that's bolted to the transmission, but I plan on adding some more rear support for that motor. One of the next videos I'm going to do is to create a rear mount using that strap around the motor and the stock mustache bar. And now that I've got the motor installed, I can install the mustache bar and then know how to measure and chop it up and to re-weld it and to make it all work. And I'm probably going to create some little bobbins, some rubberized bobbins or shock absorbers for that to mount to. So that'd be a good next video on the rear mount. I also took the shift tube off, and I'll probably try to tackle this tomorrow, but I'll just show you the results of it in the next video. But after doing some measurements, it only looks like I mentioned like an inch shy, but I'm actually just about, I think my measurement was 7/16. Just less than a half an inch is all I need to get added to this to make it work. So I found this old garden tool handle that's all bent up and messed up, but it's got the same diameter. And so I think this will be a perfect thing where I could chop this up, a piece of this off, and weld it onto there and extend this out, that 7/16 that I need to make the shifting work. So once I get this shifter installed in the rear mount, I'll then work on finding a battery that I can test the motor and go through the gears and do a full end-to-end test. But until then, I'll just cut this video and call it done. We've got our transmission and axles installed, and we've also installed the motor to the transmission. So we got 2 tasks knocked off our task list. Well, thanks for hanging out with me on this video. Pretty big milestone here. We got a drivetrain installed, and I'll see you on the next one. Take care.